mission of XAI and Grok is to understand the universe. We want to understand the nature of the universe so we can figure out what's going on, where are the aliens, what's the meaning of life, how does the universe end, how did it start.
Grok-III, an advanced AI system invented by Elon Musk's AI startup XAI, has made a startling discovery in the data from Google's Sycamore quantum processor. Sycamore stands out for breakneck computational speeds that far surpass classical supercomputers. Yet Grok-III detected a mysterious repeating structure in the chip's output. This anomaly raises big questions about how artificial intelligence and quantum systems might reveal unexpected patterns carved from the fabric of reality itself. Let's explore whether we stand on the threshold of a profound shift in scientific understanding. This approach let it distinguish unusual spikes from expected fluctuations before researchers ever laid eyes on them. In that initial stage, nobody expected Grok-III to unearth anything truly groundbreaking. The point was to keep an automated eye on drift trends and error rates. Still, those behind Grok-III's development realized that I had already been transformative in fields like image recognition and natural language processing. If quantum computers were going to scale, they reasoned, an analogous revolution in automation and anomaly detection might be essential for handling the complexity. What began as a specialized tool for quantum debugging eventually paved the way for the big mystery: the discovery of a repeating pattern that standard tests and theories could not readily explain. Historically, artificial intelligence in quantum computing was still at an exploratory phase when Grok-III came along. Before that, AI mostly played a role in classical optimization tasks, such as refining gate sequences or controlling hardware parameters in smaller labs. The synergy here, pairing a cutting-edge large-scale quantum chip with a versatile AI watchdog, marked one of the first times an AI was so deeply integrated into daily quantum operations. That synergy, it turned out, also made it possible to detect anomalies that might otherwise have gone unnoticed. The growth of AI in quantum research. While Grok-III carries out specialized tasks at Google, its emergence fits into a broader trend of AI being deployed in quantum research labs. So when Grok-III flagged a consistent structure, the first response was a wave of self-checks on the electronics. But the outcome pointed to the data itself having a real repeated core, unaffected by typical hardware fixes like calibrating out crosstalk between lines or swapping cables. Even minor anomalies can balloon in complexity at higher qubit counts, which is why synergy with AI detection is seen as crucial. Grok-III's mission and early findings. From the outset, Grok-III aimed to be more than a glorified spreadsheet tool. In typical operations, the AI would produce dashboards showing qubit performance, error counts, and potential red flags. Everything was systematic and rarely surprising, until the day it highlighted a repeating structure that did not fit standard categories. The anomaly seemed mild at first, barely a blip among the usual data, but repeated calibrations did not erase it. Even partial reboots of the system left the structure lurking in new runs. Grok-III effectively asked, "Are you sure this is noise?" Over and over. Technicians ran old versions of Grok-III to check if a recent software update had somehow introduced a bug. The older versions, tuned with less advanced methods, still spotted the repetition, though at a lower confidence level. But even that was enough proof to say this phenomenon went beyond an AI glitch.